Thank you, Julie, for handing over the mic. Uh, I would like to introduce Mansoor Ali Khan. Mansoor Ali Khan is a mechanical engineer with a master's degree in business administration. He brings extensive and diversified experience from 48 years in industry, service sector, academics in Pakistan and overseas. He has worked at senior management levels in cement, power, insurance, rising to senior management positions. He worked as general manager and licensed surveyor for a loss adjusting and risk management company in Pakistan, providing services to local insurer, international underwriters, reinsurers, and brokers. Currently, he is working as technical advisor in property risk management at EFU Insurance Company Limited. Now I request Mansoor Saab to please take this forward.
Thank you, Fahim, and good afternoon, everybody. Fahim, thanks for the very kind introduction. It's a privilege to be here addressing or presenting to this audience through this webinar. The subject that we have chosen or has been chosen is industrial safety. As you can understand, this is such a big topic, and 1 hour is probably never going to be enough, or 6 hours is not going to be enough to do justice to what the content is. However, understanding that we have a time limitation, so what I've tried to do is condense some basics into this 45 or 50-minute presentation, with the emphasis being on a lot of visuals rather than type content. That way, the audience, whom I'm sure are all familiar with the subject, would be able to get a sense of how, safety is achieved and how safety is compromised, and how the lack of safety leads to losses, accidents, and a general feeling of depression everywhere it happens. So let's kick it off. This is the outline for today. I'm just going to walk you through some basic industrial hazards and why safety is important, and then we'll go into the specifics of who's involved, how it's done, what are the good ones, what are the not so good ones, and what are the really terrible ones. And finally, what can we learn? And then we'll take questions from wherever they are, and Julie is going to receive the questions, and she's going to read them out for us to answer them. Thank you. So if you take a look at this visual, it's a flatbed truck with a whole lot of cargo on top of it. Not a very convincing or a pretty sight for somebody who's following or coming from the other side. But this is just to illustrate. Look at the questions at the left. There are 6. What can happen? Why can it happen? How can it happen? When can it happen? How likely is it to happen? And what will be the likely consequence, right? So this picture gives you the answers to all these 6 questions, and very quickly. So anybody who's been in this business, who's involved with safety, involved with risk management, can take a look at this picture and say, of course, this is a hazard. Yeah, it's very poorly packed and loaded. It's already listing to one side. The truck can overturn. So what can happen? The truck can overturn along with the car. Why can it happen? Why? Because the load is 1, too much, and 2, it's unbalanced. How can it happen? A bump on the road, brake, a turn in the road, a distraction by the driver, anything. When can it happen? Any time. From the looks of it, it could happen anytime, now, or maybe in 10 minutes. And how likely is it to happen? You ask me, 100%. And what are the consequences? Well, of course, damaged cargo, hazard to oncoming traffic, injury to the driver, damage to the vehicle, and a big mess on the road. So one picture, 6 questions, and a short narration tells you, well, if this whole thing had been done differently with the word safety in mind, the outcomes to all the 6 questions would be very different. Anyway, so safety basically is a state of mind. It's a mindset. It's an awareness, and it doesn't necessarily have to be practiced in an industrial environment. We all know that we practice safety everywhere, from the time we wake up in the morning to the time we go to bed. Some safe acts are being performed. Not walking on a slippery floor, careful going down the steps, careful crossing the road, careful while driving, careful while riding a motorbike. Okay? So, all these actions which human beings do are safe or unsafe. In which case, you know what happens when they're unsafe. So, if you read the text, it's just a very short paragraph of describing or defining workplace safety. And when I say workplace safety, we don't exclude non-industrial workplaces either. So a shop, a kitchen, an airport, a bus station, a train station, uh, anything can be a workplace. So what is important? Safety, health, well-being, and the environmental hazards which can contribute to making these places unsafe add to the risks and hazards which human beings always run. Uh, Quick list of, I apologize for the size of the font, but I'm going to read it through. Hazards are caused by accidents, by chemicals, by physical conditions like noise, vibration, heat, cold, poor ventilation. Ergonomic hazards. You have an uncomfortable chair, in 3 months' time, you're going to have a backache. So if you have a desk job and you're sitting in an uncomfortable chair or a poorly designed chair, you are going to have a backache. Lifting heavy objects without the proper posture, that's another ergonomic hazard. Then biological, animals, plants, waste, contact with them is another hazard, and it causes skin ailments, it can cause blindness, it can cause all sorts of respiratory uh, uh, infections. I worked in the cement industry for many years, and there was a research done that at the end of a career, 27% of employees from cement factories had lung problems because they were continuously in an environment where they were inhaling cement, clinker, dust, as compared to normal people who also inhale plenty of dust, but not at the same levels as cement players. So that's in itself a hazard which can cause health problems. Working conditions, again, you make somebody work 12 hours, 14, 16 hours every day for weeks and weeks, and you're going to just burn him out. So eventually he's going to get tired, his attention is going to get diverted, and there's going to be an accident. He's going to hurt himself or somebody else, or he's going to fall sick. Poor sanitation, lack of security. If everybody is scared going out, I might get mugged, I might get robbed, I might get run over by a bus. That's another hazard. And then finally, abuse, psychological abuse. You shout at somebody, you humiliate somebody, you uh, generally don't be kind to them. That's another hazard. It has a tremendous effect on many people. And why these are important is because The consequences of being affected by these hazards leads people to do unsafe acts. And the whole point of safety is that if you are not in a mentally fit state, then you're bound to have the higher risk of an accident. And let's watch out for these. Now, if you take a quick look, again, the font is small, so I apologize. There are 8 segments on this spinner wheel, and 6 of them actually relate to human beings. And I'll read it from the top left in attention to detail. Okay? You say, yeah, I got it. Don't worry, I got it. You know, and you haven't thought it through, read it through, or considered everything, and so you miss some things. Inadequate warning signs, yeah. Be careful. That's not an adequate warning sign. The be careful should be qualified. There's water, there's ice, there's a road crossing, there's animals crossing, there's a slippery floor. Be careful is not enough. Training, yeah. Safety has to be drilled into people all the time. For years and years, I've seen this in my career. I've seen other people. I've seen well-run industries. The emphasis on training, retraining, training, retraining, it just cannot be second-guessed or discounted. Human error. Okay. So human error is something that a lot of us don't have control over. Okay. Sometimes, someday, some point, people will make a mistake. All right, fine. One mistake, you counsel the employee. You explain, hey, look, this is how it's done, and he repeats it. Oh, now we have a problem. So what happened this time? Why did you make the same mistake again? And so, discipline is important. You let it go once, you counsel, you teach, you coach, but to avoid further accidents, you need to sit back and say, look, this is enough. We need to replace you or retrain you or move you away or do something else. Asleep. Okay. Asleep is, again, fatigue, habitual, having a late night. Okay, not getting enough rest and sleeping at work. Dangerous, and it has caused many accidents. Right? Act of God. So that's, I'm not including that in the human part. Act of God is, earthquake, tsunami, rain, windstorm, etc., etc. You can't do much about that. However, those are hazards. However, in areas where such acts of God are common, people take steps to manage it as best you can. So you reduce the negative impact of the act of God. That's what you do. Bad procedure, again, who writes procedures? Human beings write procedures. Nobody can write a perfect procedure, but once you practice it, you start to correct it. And that's the beauty of procedures. They're always up for review. And for those of you who are familiar with the concept of management of change, what is management of change? You're using a particular practice for years. Okay, you find, no, this doesn't work. We have ABC corrections, so you make that correction. That becomes the new procedure. A year later, you may decide to reduce it, make another procedure. So this is a continuous process, and this is also a hazard that does happen, can happen, will happen, unless you take steps to correct it. The next one will be equipment failure, right? So equipment doesn't fail by itself. The machine is a slave to the operator. It's designed to perform a certain function. It will perform that function or functions till such time as it can. So the machine needs to be looked after. How? Keep it clean, keep it properly lubricated, keep it frequently inspected, keep it frequently serviced. See? All these things are laid down by machine manufacturers. Service intervals, lubrication intervals, overall intervals, inspection interval. You just run the machine, keep running it and running it. One day it's just going to give up on you. And that's when the failure occurs. Again, this is a failure, it's an equipment failure, but it's actually caused by the human. The machine won't fail if somebody paid attention to it. Unknown. Oh, okay. So it's the fine print says spin again and don't tell anyone. So there's many things in this world which we pass off as unknown. Okay. As a loss adjuster, I can share this with you. So many times we have seen, we don't know what happened. We have an insured gets as an accident, has a damage, and you ask him, okay, can you tell us what happened? And they turn around and say, I don't know. We don't know what happened. You know, something did happen, but we don't know what happened. Kind of hard to believe that we don't know what happened, or kind more like, you know, we know what happened, but we're not going to tell you because we want our insurance claim. And so that's life. That's human beings. But very few causes, very few accidents, very few safety lapses have unknown reasons. And for those of you who've heard about the Bermuda Triangle, yeah, today it remains a mystery today. You know, ships disappear and boats disappear and all sorts of funny things happen. And nobody's been able to explain what happened. What is the Bermuda Triangle? There are thousands and thousands of theories and stories, and movies have been made, and all sorts of things happen, and yet it remains a mystery. So this may be one of those unknowns, you know, right? The abominable snowman, this guy who keeps walking around the Himalayas. We don't know what he's been up to. So maybe he is somebody, maybe it's not, maybe it's imaginary, maybe it's an animal who hates human beings and keeps himself hidden. Anyway, so this is the spinner cause. You know, all these things you got to watch out for when you're involved with safety management or being part of safety teams or anywhere. Look out for all this. So acts of God. I just want to show you these visuals that, okay, they're acts of God, like the earthquake, shocks, earthquake, fire, tsunami, storm, floods, drought, etc. They're all acts of God, right? But they have consequences. One of the consequences is that it causes a lot of misery to human beings and animals and livestock and the nature at large, the crops, the forests, the rivers. That's one part of it. But these same perils become safety hazards because they occur in areas where people live, where people plant their crops, where people graze their livestock, where factories are set up, where workshops are set up, where industries operate, where highways and bridges and dams and roads exist. And all these become safety hazards to human beings and to construction. Now, can you avoid a volcano eruption? No, you can't. It's not been done so far, so. But you can manage the fallout from the lava which erupts from the. And now they have these research centers and satellite imaging systems where they can predict the eruptions to within a few minutes. And so when they have advance warning, they will evacuate the area, they'll clear off, they'll help people move away, they'll clear the path. So whatever damage the lava does not affect that many people. Same with flood. Okay, frequent flooding in areas people manage. Okay, and just to give you the most recent example was the rains in July and August in Pakistan and the amount of damage. So all of the participants here who are from Pakistan would very well know the amount of destruction, loss of life, property, materials, animals, livestock, crop that was damaged due to the rains. Now, rains is an act of God, but rains is not an unknown act of God. We know it rains in the monsoon. We know that there is a snow melt every year. And we know the snow melt causes the rise in the rivers. We know the river banks overflow. So there's a whole bunch of stuff we know. But beyond that, to create the safety net for those who might be affected, we wait for it to happen. We wait for it for people to get flooded and homeless and die and get washed away, and they say, oh, now we're going to do something. Right? So that firefighting approach as against a proactive approach is again a natural peril causing a safety hazard, but not managed properly by human beings. A little, a little bit of a insurance perspective for those of us, the participants who are from the insurance business and even those who are not. So this is just a sequence of a hazard will cause a loss incident, will result in a loss. Okay. So if a hazard is not managed properly, it will cause a loss. And I've referred to two types of hazards, fire and non-fire. So, and both of them are perils, but of different natures. Loss incidents result losses, and there are direct losses. So you have a building which houses cotton garments or garments, and there's a fire. So the building catches fire, the garments catch fire, the building burns down, there is a material loss. X million rupees or X million dollars or X million pounds of material loss. But there's an indirect loss to that also. That material was destined for a customer. The factory owner had an order. There was a shipping deadline. Okay. That whole material has to be remade. First, the factory has to be rebuilt. The material has to be repurchased. Then it has to be finished. Then it will be shipped. These are the indirect losses as a consequence of the direct loss. And in insurance terms, as most of you know, we refer to them as business interruptions. And insurers, of course, offer business policies to cover business interruption losses also. All right, so let's go on. Now let's get to the, what I want to talk about now in the next section is to talk about how an industrial concern and the management of an industrial concern will take steps to manage the aspect of safety for all its operations, whether for its human beings, for its assets, for its stakeholders, for its customers, for its, let's say, third party, its neighbors, the people around him, the government, everybody. So when we say who are involved, we list employees, contractors, visitors, The emergency response team, this is the go-to team, the specific people designated to take care of safety arrangements within an organization. The local management is normally the fire brigade, the local police, the hospitals nearby, the civil defense services, etc., who provide services in the event of an emergency and who also have been trained and have expertise in disaster management or accident management. Now, but what does an organization need to be able to put all this into a coordinated effort, into a proper, what we say, a safety management system? What do we need? We need procedures, we need practices, you need emergency plans, and you need training and drills. So, safety procedures. Okay. Companies normally write out comprehensive safety manuals for their staff to cover all aspects of their operation, whether it's incoming raw material or storage of materials or work in process, finished goods, packing, finishing. That's one part. Then they provide for safety at work for the human being, the ventilation conditions, the lighting, the air conditioning, the quality of the floors, the separation between equipment, the guarding of rotating equipment. You'll be surprised how many accidents just take place because a belt drive does not have a guard. The guard came off, somebody took it off, forgot to put it back, and somebody walking by got his clothes stuck in it and got stuck to it, lost an arm, lost a leg. For what? For missing two bolts? So the procedures are there, the practices are there, and then that's for normal operations. Then you go to the next step, that what happens if something goes wrong? What happens if there is an accident? What happens if there is a disaster? What happens if there is a terrorist attack? What happens if we have flood water coming into this? What happens if we have an aircraft crashing into what happens if a runaway truck collides into the boundary wall? X number of possibilities. So you always make preparations for emergencies. And what are they? They are in the form of plans. What if plans? If this happens, A, B, C, D. If this happens, A, B, C, D, and on and on and on. And it's not that it's, you're waiting for something to happen, but it's always there. And all employees, including the ERT team, which is the go-to team for these things, are trained, drilled, practiced in what to do if something goes wrong. This particularly should apply, and I want to raise this point here, is for people who are new to the organization. They may have come from another organization where the safety practices were different, where the conditions were different, where the approach, the management approach, the philosophy, the awareness was different. They are the ones who need to be very quickly, as soon as possible, inducted into your own safety management. Dress code and driving code and safe operating of equipment code and everything, and health conditions. All these aspects are part of good organizations, especially industrial, in the fertilizer business, in the petroleum sector, in the chemical industries, in the refineries. The induction of a new employee lasts up to 2 to 3 weeks, where they're trained and drilled before they're actually put on the job. That's how much importance they're given. Right, so this is just a repeat Fire procedures, since safety covers so many things and every industry has different safety needs, so I just going to limit it to what to do to prevent or to manage any hazard which has a fire related consequence or is caused by a fire. So fuels are the most vulnerable to fires. What causes fires? Definitely an ignition source. It could be heat, it could be a flash, it could be a thrown cigarette butt, it could be a stroke of lightning, it could be anything. But a source of ignition is there. Inspections, yeah. This is the key to good safety management. Inspectors within the teams, within departments are continuously on the lookout just to see, is everything okay? Am I missing something? Is there something wrong? Is this becoming a hazard? Has somebody left a wet, oily rag near an electrical wire? Things like that. And a lot of accidents, and my loss adjuster friends and risk managers would agree, a lot of accidents do happen and are caused by such minor lapses, which can then escalate into a major event. All right, so now from here on, I'm going visual with some of the things which most of you have seen or would have seen, and if you haven't, well, here's what it looks like. So, housekeeping, keeping the place clean and neat and tidy. All right, this is the mindset. You know, you'll find housekeeping in many organizations just really, really sloppy, untidy, and not because they can't afford to. It's just not the awareness is not there. Nobody bothers, and the pictures on the left will show you. See, it's a powder which has been spilling, and it's just lying there. Nobody bothered to clean it. That's it. On the right, just take a look. Stacking it up, cardboard, cotton, machine, tables. I'm sure if they had a proper place for everything, it would look much tidier and be much safer also. So it reflects what? Safety awareness, and it reflects the attitude of management. If the management has an attitude and the manager or the plant manager or the floor manager or the supervisor walks around and kicks a few people around and say, look, I don't want any rubbish around here, and makes a point of it, see how quickly things change. But if I walk around and I go past a pile of rubbish and just say, oh, okay, never mind, somebody will pick it up later on, it never happens. So the attitude of management is actually much more important than the safety awareness. If the attitude is positive, if we want to please keep our place clean, our place being clean will make our place be safe. If that's the sequence of thought process, this works. There you go. More examples, huh? See the way you stack things? See the way you keep things? What is this? Waiting for an accident to happen. And here we are. On the left, put everything in the shelf. On the right, sort it out, put them in order. How hard is it? The picture tells you, you know, this would take 20 minutes to fix. Sorry, this slide is out of place, but anyway, quickly. Thermal, electrical, mechanical, and chemical. There are 4 types of energies which become ignition sources. So flames, overheating, friction, and reaction and decomposition heating. So By the way, you can't avoid them being present. Why? Because in every industrial unit, in every factory, in every workshop, there will be, these sources will be present. However, you don't need to let their presence become the source of an accident. So if you have an open flame, make sure it's protected. Make sure that that open flame does not become an ignition source for a fire. Make sure a hot surface does not have, people don't have access to a hot surface. Same for overheating, same for lighting, same for friction, decomposition. You don't clean out trash, it will decompose. When it decomposes, it becomes toxic. We see what happens in so many times in the, you see these municipal cleaners, the people who are responsible for keeping the drains of our city clean. So many people die because they inhale toxic gases. Why? Because the drains have not been ventilated properly and the waste has decomposed and created toxic gas. And when they went there to clean them, they just got lost their breath, and that was it. That was the end of their life. Okay, so this is one thing that has been the cause of many accidents, many times. And this is welding spatter. Okay, the visual is not all that fantastic, but I'll just run you through it. If you look at the left picture, the man on the steps is welding at a height, and now you see what the spatter is doing and how far it is going. The sparks from the electric welding process are going 2.5 meters to 10 meters. And even at 10 meters, it can cause a fire. So see how far it's traveling and the pressure with which it's traveling. 2.5 bar, 5 bar, 7 bar, and up to 10 meters away. So any activity that involves open flames or sparks or hot droplets such as welding, cutting, grinding, soldering, torching, etc. can cause this sort of accident. Okay. Only 2 years ago, a steel mill near Karachi had a fire accident which was apparently caused by exactly this. The spatter fell down, there was some waste oil and rags, they caught fire, and the entire mill stand was destroyed. Okay. So this is an ignition source control which can be done, can be controlled. Hot work permits, the reason for hot work permits is for this particular type of work anyway. Make sure that the entire area, the people working, they've got the right tools, they've got the right procedures, the machinery, the equipment, and everything around it is protected and safe. And that's how a hot work permit is issued. Okay. And follow-up checks. Once the work is done, there should be a follow-up check just to make sure that nothing else has been left around. Again, from my experience of all these years, I can say that scores of examples where a hot work permit was issued but not issued correctly and an accident happened. So the accident happening on a hot work permit is just too little too late to say, yeah, we had a permit. Yeah, you had a permit, but it was no good. Again, now, so all these visuals are just examples of open flame practices. And this happens everywhere. Just, this is not something which I brought from outer space. They're all Google pictures. You can look them up and you can find thousands and thousands of them where these are real live accidents of people who did not take enough care. Look at this, beauty, electrical, See how sometimes at home you got one multi connection and you got 6 things plugged into it, huh? Everybody's got his charger and his phone and his TV and his laptop and everything is plugged in. Then your mom comes and she plugs in the microwave also. So what's going to happen to it? That's what's going to happen. And this is a big one, $18 million of damage caused by an electrical fault. And the consequence was there was tremendous amount of combustibles lying in that area, oil and rags and storage materials. And the outcome was what you can see in the visual. Huh? The whole factory burned down. This is a garment factory in 2017. The claim was $18 million. This is not small change. Okay. Inspection. See, 2 pictures, the middle one and the right one. Huh? Both are the same equipment, but look at the difference. And what has caused the difference? The one in the middle is in an area or in a factory or in an industry where there's an inspector walking around with that clipboard in his hand and making sure that the hose reel, the nozzle, the connections, everything is intact and clean. And the one on the right has an inspector who probably doesn't even come to work. So this cabinet has been opened after 6 or 8 months, and you can see what it looks like. And there's other stuff. There's a water bottle there, and there's other things there. So imagine the outcome when a fire occurs and you use the middle one, and you have to use the right one. There'll be 2 different outcomes. And I can't emphasize this aspect enough. Training. Okay. These are pictures from fire training of a Japanese book, and the Japanese are the ultimate when it comes to training. But it can apply to everybody, and it can be done by everybody, and it is practiced by many safety-aware organizations. Yeah. To understand what do you do if something goes wrong? First, you need to inform everybody, raise the alarm. Okay, where is the equipment? You should know where the equipment is. How do you use it? You should have been trained how to use it. And who's going to lead the muster point and the staging areas and the collection, and everything is drilled and drilled and rehearsed so that when and if an emergency occurs, we can respond to it quickly. Okay, it looks like I'm nearly about to run out of time, so I've got this to say at the end. What can we learn? So it's not been an exhaustive session, but what can we learn? Time, distance, and cultural barriers. Everybody is not the same. You, me, the participants, the rest of the world, they're not all the same. So we need to understand. You need to explain to people within the context of where they work, where they come from, what their role in the job is, and what their understanding of safety awareness is, and understand that the language used and the tone and the approach used can never be one standard approach. Okay. Teach by lessons, teach by experience, show them these visuals, show them things that are done well, show them things that are not done well. The lessons are a very good teacher always, especially in the case of safety, because you can't make accidents happen just to show, okay, we are not going to go have 2 buses collide so you can see what happens when an accident takes place. No, you don't want to do that. But what you do want to do is to show them that, look, this is how an accident occurs. ABCD happened, an accident occurred, and then this was the consequence. And he said, you said, they said, we said, no. Blaming never helps. Never helps. Should be avoided, just causes more depression, frustration. And you're trying to teach people, okay? You're not trying to hang people. Share the positives, yeah. There are positives. The negatives are that somebody is going to get hurt, somebody is going to lose, somebody is going to be impaired, somebody is going to be disfigured, somebody is going to be handicapped. Remember, no matter how much we talk about asset safety and integrity and all that, at the end of the day, the safety that we're talking about is the safety of people. So you lose a limb, you lose an arm, you can't go to the supermarket and buy another one. That's for sure. You can't go to the OEM because he's not around and say, I want to buy a new arm. And that's the mindset that needs to be drilled and inculcated. Human safety is much more valuable than assets. And remember, it's only recent history, Columbia 2003, Piper Apache, Baldia town in Karachi, where we're speaking from right now, and where quite a few of the participants may be on. Very recently, in the last couple of years, we've had two major disasters in Pakistan. The Bulleh Shah paper factory fire lasted about 72 hours. The Ruby textile. Now, these are all live examples of safety related accidents. Okay? None of these were acts of God. None of these had unknown causes. Most of them were human error, lack of attention to detail, okay, incorrect procedures. All right. Okay. Julie, it's 10 to 5. If you have questions or if you give me a few more minutes, I have a few more slides to look at.
We've got a couple of questions, but you've got a couple more minutes if you'd like to finish up, and then I can give you the two questions.
All right. Okay. So, okay, thanks, Julie. Again, these are visuals. Look at, the fire extinguishers on the left and the ones on the right. Yeah? You can reach those, but try getting out one of these. Storage conditions, okay? Just put the cotton wherever you feel like, on the floor, side, wherever you like, just put it in. Or stack it properly. There you go. Oil drums, chemical drums. Look at that. Look at this. Here. Now here's an example. Housekeeping. Look at the housekeeping on the left. Eh? It's not done by aliens. It's all human beings. So somebody took the time and effort and trouble to design and probably lay out a warehouse area and put it on. And the other guy said, all right, yeah, I've got that much space, and so just put everything on the floor. And we're done. There you go. Here's my man. Safety helmet, safety belt, tool kit, goggles, gloves, everything. And my friend on the right is a newspaper instead of a welding mask. He's got a newspaper. Okay, that's great. And he's welding. And I love this one. So no disrespect to cats, but the cat is not an electrician. So you don't expect her to go and fix your internet connection, which is what she's trying to do. So use the right person, the right tools, and the right training for the work that we do. And there we go. Prop up the vehicle, don't use the jack, just sit under it and pray that nothing falls. Beautiful. And by the way, these two pictures of these electric connections are from an industry where I took these pictures. So I actually saw this live. So I didn't pick them up from the internet. This is a classic, an old fire tender, not much use, got a flat tire, and you won't be able to take it anywhere. There we go. This one's going to catch fire soon, if at all. And there you go. Thank you very much, everybody. I hope you enjoyed it. And if there are any questions, I'm right here.
Thank you. That was a really informative presentation. We have two questions. So the first one is, stringent and rigorous safety measures may affect the productivity and quality and eventually the financial bottom line. Can you kindly highlight some effective methods to balance safety, production and quality?
Okay, Judy, can you say that once again? Balance, safety,
Can you some effective methods to balance safety, production and quality?
Okay. All right. So this is never an easy balance. The production manager will want to produce, the marketing manager will want to sell, and the QC manager will want to apply the strictest of standards to quality. And the safety guy will say, all right, fine, but A, B, C, D has to be done in terms of safety. Now, earlier when I was talking about the attitude of management, that is where the balance comes from. The management takes the lead and says, all right, we will not compromise on safety. That's one attitude. And I'm not saying every management takes that, but that's one attitude. Now, granted, some of that attitude will have a cost which will impact the production. It may. However, that's the trade-off. You want it to impact production or you want to compromise it. So you need to keep a balance. On the issue of quality, again, this is a personal opinion and, everyone is welcome to challenge or to question it. I believe that the customer deserves the best quality that you have committed or promised or claimed to provide. Okay. So for every product, whether it's food or it's an electronic item or it's a car or a motorbike or even a plane ride, if the provider says this is what you have to pay and this is what you're going to get, and expect the customer to accept less, that's not fair. So my submission is to this question is that yes, you can create a balance between safety and production. However, I would not include quality in creating the balance.
Okay, thank you. The next question is, at the end of most of the incidents, it is found that short circuit is the proximate cause of fire. How can we find the exact reason of fire in these cases or minimize the occurrence of those events? A nice easy one.
So, after all these years in the industry, the word short circuit is to me a really dirty word. Why? Because it never explains anything. And yet, it seems to be the cause for most accidents. Now, unfortunately, the outcome of a short circuit happens way past the short circuit occurrence. And there's no way of going back to relive the moment where the short circuit occurred. The other thing is, why did the short circuit occur? Again, cause, spin a cause is, yes, the electrical systems have short circuits. No argument on that. Yes. However, short circuits do not occur in a normally installed operating electrical system, i.e., the right quality and standard of wire has been used, the right quality and type of jointing has been used, the right quality of junctions have been used, the right protection, the circuit breakers, the solenoid, the protection sensors, they're all there. And I'm talking about a simple electrical motor which has 2 kilowatts or 5 or 10 or whatever. So if all that is in place and the connections are not loose and the motor is inspected, there is a very small and slim chance at a short circuit. However, having said that, I'll start with most of the short circuits in low voltage electrical equipment occurs because of substandard material. The 5 amp shoe which you use to plug into a socket, okay, it has 5 or 6 moving parts. Can you imagine that? It's 5, 6 moving parts. Any one of them can get loose. There are small screws which hold the cables. Then there are clips. Then there's a screw which holds the 2 plastic pieces together. Any one of them can get loose. And when it gets loose, it's going to cause a connection block. And when the electrical current is flowing between a joint, of course it's going to heat up if it's loose. And that's where short circuits occur. Now, go to the other end. Cable is always specified by the designer. There's a particular standard. There's a particular rating. There's a particular amperage. Okay. The first time the manufacturer sells you the equipment, it will have the right. The moment it gets serviced, invariably the cable standard has been changed. And to the gentleman or lady, whoever has asked the question, I could go on and on with short circuits, but believe me, if somebody tells you that this was a short circuit, don't buy it. Ask, go, drill deeper. Try and get to the bottom of it. And if 9 times out of 10, you'll find out that the short circuit was caused by something else.
Thank you for that. We just have
one long answer to a very short question.
No, you're getting very difficult questions today. So this is one last question, and then we'll see if Fahim has any questions for you. What is the major difference between qualitative risk assessment and quantitative risk assessment?
Qualitative and quantitative?
Yes.
All right. Okay. So qualitative risk assessment, I have 3 experts sitting here. So I should probably not be answering this question, but I'll try. Qualitative risk inspection is based on what? Is based, if I was to, answer it, I would say, okay, I have been in the business for 45 years. I have been to 200 different industries for risk inspections. I've seen this, I've seen that, and all that is in a database somewhere at the back of my bald head. And so when I look at something, I say, now this is a good risk. Good risk, yeah. Good is so relative. It's a good risk. Why? Because I compare it to A, B, C, D, E, which were better risks, and F, G, H, I, J, which were not so good risks. So the basis for assessment was a comparison between two sets of risks, which I've had the experience of. Now that is totally qualitative. Okay. No calculations, no pictures, no interviews, no case studies, no loss records, nothing. No evaluation of procedures, etc. Totally qualitative.
Risk matrix is going to be called risk matrix.
I'm coming to that. So now the second part of the question is what quantitative. And the quantitative risk assessment is you have an SOP, you have an operations manual, you have a maintenance manual, you have a safety manual, you have a quality manual. Okay, you test those. You pick up the safety manual and say, all right, guys, what is your method for testing your fire water pumping systems? Okay, how frequently do you do it? What do you do with the results? How frequently are corrective actions taken? So they show you a logbook and you can have a look and you can take, and then you say, all right, fine, this is great, we understand. Now, can we do a demo for us? So we go out to the fire station and say, all right, switch on the pumps. Let's see how it works. Check the pressure gauges, check the flow rate, okay? Check the nozzle angles, check the way the monitors are operated, check the way the operators actually handle the equipment, check the response time to unfurling a hose reel and setting it up and getting the pump going, and check the auto systems, whether it's on auto or manual, so many times. Okay, and here's, you can check this out. I've been to an installation where the pump systems are supposed to be in auto, gone up to the control panel and seen all of them switched off. Brilliant. So that's all you need. You have a fire and you have your switches on off. So first you need to find somebody who goes switch them on and then start the pumps and then try and get the fire out. That's not done that way. Okay. Okay. And now with technology and all the software that's going around, a lot of insurers, reinsurers, risk assessment companies have developed risk assessment matrices. And they rate each aspect of an organization's functions based on a scale. Okay. And when you go out to the site and do the physical inspection, the surveyor then rates it. The software calculates the risk rating and gives an outcome. That is quantitative. And the reason why it's quantitative, the reason it's now very globally accepted. You send a matrix type assessment to a reinsurer or to a bank, it is accepted. You send a description, an essay written by a surveyor saying, I saw this, I saw that, this is good, this is not so good. Nobody believes. Because that's just, that opinion could be totally colored also. So again, a long answer to a short question, Julie.
Thank you. That's it with the questions. Fahim, do you have anything else to add before we close today's webinar?
No, I must like to thank Mansoor Saab and all the audience who have listened to the webinar. Thank you, Julie.
Thank you, everyone, and thank you for an excellent presentation. I'd like to remind everyone that the webinar is being recorded and a copy will be placed on the IIRSM YouTube channel in the next couple of days. Good afternoon, everyone.
Thank you, Julie. Thanks very much for your help, and to the audience, thank you very much for your patience and for listening to me. I hope it was useful, and if you have any questions, of course, you can reach out to me or to IIRSM, and we'll be more than happy to answer. Thank you and goodbye.
Bye.